Hey, fourth graders, it's Mr. Rogers and
Mr. Bing.
All right, so we have a little demonstration behind the camera. We have Miss Frank. She's going to come out in a moment. Great. Hi. All right, so we are talking about Newton's second law of motion in this video, and one of the experiments we're going to go through is called the stand-up challenge. Now, I know it's COVID and we shouldn't be doing this. Mr. B and I washed up before we did this activity, and we'll wash up afterwards. But one of the activities to represent Newton's second law is this stand-up challenge. I'm going to sit back to back with Mr. B, and we're going to stand up, hopefully, by pressing our force against each other. And if we put it together, it'll go up, and we'll be happily standing. Whatever. So, with that being the case, the second law of motion is force equals mass times acceleration. Now what's interesting is Mr. B and I are about the same mass, which means we're going to press against each other with about the same amount of acceleration too, which means we're going to be balanced. After we're done this activity, Miss Frank and I am going to do the same activity. And Miss Frank and my mass are two totally different numbers. So because of that, we're going to talk about what has to happen for us to stand up. So, should we try?
Let's do it.
All right, back to back. Hopefully we don't slide. We're going to link arms. All right. Get our feet prepared. And on the count of three. 3, 2, 1, go. Ta-da! The stand-up challenge. Now, Miss Frank, come on out here. Now you notice Miss Frank is not the same size as I am.
Not as massive.
Now, because of that, we need both sides of the scale to be even. So since I have more mass, what will Miss Frank need to do? Well, she could become larger. That's not going to happen for this activity. But she could increase her acceleration. If she can press hard enough into me to overcompensate for my acceleration and mass, we'll be able to stand up. Should we see if it works? Again, we got to find balance. We'll see if she's strong enough to get us to stand up. Here we go. On the count of 3. 3, 2, 1, go. All right, unfortunately, because I am too big, thanks, Miss Frank,
and I am too weak,
she is not able to put enough acceleration into my back. We weren't able to find an equal balance and allow ourselves to pop up, okay? That would have been the ideal goal. This helps prove that force equals mass times acceleration. Unfortunately, we weren't able to do it. Mr. B, thanks for being someone that makes me feel better about myself.
You're welcome.
All right.